Welcome back again. Hope by now you have seen the first lecture on video lecture on work done by constant force, where I explained the definition of work done and how it is found out and how it is the dot product of the force and the displacement. Now, and I solved also two numericals in the first lecture. Let us go to another one quickly. Okay, well, you can expect this kind of problems in your JEE main, not JEE advanced, and also in NEET examination, but very likely in your board examinations, unless it is very tough. Now look at the problem. A particle moves along some trajectory in XY plane. There was no need to draw this XY plane, but I have drawn it to explain you the two position vectors R1 and R2. So a particle moves along some trajectory in XY plane, x-axis, y-axis. So this is your XY plane, and the position vector of the point P is given by R1 is equal to I cap plus 2j cap meter. So let me show it here. I take it this as R1. This point is P. I cap means 1 unit along x-axis. I cap is a unit vector along x-axis. In front of I, what is written is 1. So 1 unit to this side. From here to here I have taken as 1 unit. J cap is a unit vector along y-axis. So two units along y-axis. 1, 2. So 1 to this side, 2 units to this side. So you arrive at this point P. So this is your position vector R1. So the particle was initially here. Now it moves to a point Q, whose position vector R2 is given as 2I cap minus 3j cap. Means 2 units. The point Q is at 2 units along x-axis and minus 3 units, means 3 units along negative y-axis. So let me show that point Q here. 2 units, 1 unit, 2 unit, then minus 1 unit, 2 unit, 3 units. So 2 unit to this side, 3 units to this side. Then you arrive here. So this is your point Q. So this is your position vector R2. So it was initially here, now it is here. So the displacement is R2 minus R1. And I have explained in previous video, if there are two vectors, this is a position vector, this is position vector. If you construct a parallelogram like this, now this will be the sum of the two vectors, and this diagonal will be the difference, that is R2 minus R1. So your R2 minus R1 is from here to here, that is the displacement. So this vector is your, this vector is your R2 minus R1. That I have already explained in the previous video why this is R2 minus R1. Now, and the force vector I am not showing it here, it is not required. But if you wish, you can show the force vector. The particle moves from P to Q. The position of P is known, the position of Q is known in form of I cap and J cap. And it is acted upon by a constant force, F is equal to 3I cap plus 4J cap. Means the force has a component 3 Newton along x-axis and 4 Newton along y-axis. If you want to show it, you can show it. 3 units, 1, 2, 3 units, then 4 units to this side. 1 unit, 2 unit, let it be 3 unit, and 4 unit will be somewhere here. So if you arrive here, the force vector is from here to here, from this point to this point. I have not shown it. Okay, let me show it. and then you'll be comfortable. Let me extend this y-axis so that I'll be able to take 4 units along a y-axis. So let me produce it to this extent so that I can take 4 units. 1 unit, 2 unit, 3 unit, then 4 unit will be 1 unit, 2 unit, 3 unit, then your 4 unit comes out to be I've taken 2 centimeter, 2 centimeter. Let me sew it, then solve it. 2 centimeter, 2 centimeter, 2 centimeter, 2 centimeter. So your 4 units is to this side and 3 units is this point. So if you arrive, at this point. Let me sew in a dotted line where exactly how the force is exactly acting. There is no need of this, but to have a better understanding, I am only showing you 1, 2, 3, 4. So if you produce it, so this is the point. Fine. So the position vector of the force F is equal to 3i cap plus 4j cap. 1, 2, 3. I cap is a unit vector along x-axis. 4 units along positive y-axis because there is j cap. 1, 2, 3, 4. So the point is here. So the force is acting. So the force vector is given by this. You are not interested, we can solve that without it. So this is your force vector. Now then coming back straight to solving the problem. So this is a constant force. 3 units along x-axis, 4 units along y-axis. So how this is constant? If you have done vectors before, dot product of 2 vectors is given as, let us take F is 1 vector, the dot product of the vector F with itself will be magnitude of this, angle between this and this is 0, cos 0, there was no need of it, cos 0 is 1, so F square. Now if you put the value of F, that is F is given as 3i cap plus 4j cap dot 3i cap plus 4j cap. Let us see. If you take the dot product of F with F itself without putting the values, what you get? The square of its magnitude. Now if you put the values, now 3i dot 3i, 3 3s are 9, I dot I is 1, that is all, I hope you know. I dot I is a unit vector, magnitude is 1, I is a unit vector, magnitude is 1. This I, they are in the same direction, so angle between them is 0, and in dot product we take cos theta, so cos 0 is 1, 1 into 1 into 1. So if you take I dot j, its magnitude is 1, angle between them is 90, so cos 90 is 0, so is 0. Means what you have to remember is I dot I is equal to 1, j cap dot is 1, k cap dot k cap is 1. Any other combination, I dot j is 0, I dot k is 0, j dot k is 0. So if you put it for here, I am showing how the force is constant. 3i dot 3i, 9, I dot I 1, 9 into 1, 9. Then 3i dot 4j, 3 4s are 12, I dot j is 0, 12 into is 0, 0, so I am not writing. Then comes 4j dot 3i, is also 0 because j dot I is 0. Then 4j dot 4j, this is 4, this comes out to be 16 because j dot j is 1, 16 into 1, 16, so this is equal to 25 Newton. So this is a constant. So it is acted upon by a constant force. Now to solve it, there was no need of all these diagrams. There is no need to explain this also. We can straightway use the dot product to find the work done. So let me do it in a different pace where you will be comfortable. You will be able to look at the diagram now. So since the force is constant, I can use this. So your work done is equal to F dot S. Force is given as 3I cap plus 4J cap, and the displacement is from P to Q, which is given as R2 minus R1, and R2 is given and R1 is given. So I write, instead of S, I write R2 minus R1. So that becomes 3I cap plus 4J cap dot R2 is equal to 2I cap minus 3J cap minus of R1. So since there is a minus sign, the sign will change. So is equal to minus I cap minus of plus, that is equal to minus 2J cap. That's all. So this becomes 3I cap plus 4J cap dot 2I minus I cap is equal to plus I cap minus 3J cap minus 2J cap is equal to minus of 5J cap. And I just explained how I dot I is 1, j dot j is 1, k dot k is 1, and the combination of I dot j is equal to 0 because angle between I cap and j cap is 90. J dot k is equal to 0 because angle between j cap and k cap is 0. So now it's simple. Now 3I dot I, in front of this what is written is 1. So 3 into 1, 3. I dot I 1. So 3 into 1 is 3. 3I dot 5j will be 0 because I dot j is 0. No need to write. Okay, let me write it. So its job is over. Now 4j dot 1I is a 0 because j dot I is 0 because angle between j cap and I cap. J cap is a unit vector along y axis, I cap is a unit vector along x axis. Angle between them is 90, cos 90 is 0, so I am not writing. Then 4j dot minus 5j. 4 5s are 20. I have to write minus 20. Minus 20 and j dot j is 1. So minus 20, 1 to 1 is minus 20. So that is equal to 3 minus 20, that is equal to minus of 17. Now since F was given in meter and the displacement, F was given in Newton and the displacement was given in meter, Newton meter, that is same thing as joule. So minus 17 joules is the amount of work done. So in this numerical, so the amount of work done when a body having a position vector r1, I cap plus 2j cap meter moves to a point Q, which position vector is r2 is equal to 2I cap minus 3j cap meter by a force F is equal to 3I cap plus 4j cap Newton, the work done is equal to minus 17 joules. So what you can conclude? W is equal to F dot S. So that is equal to Fs cos theta this is a positive thing, this is a positive thing, then how this is negative? So cos theta must be negative. That is, theta must be greater than 90 degree. That is, the angle between the force and the displacement must be greater than 90 degree. Now you can well imagine that here in the diagram also. You can hear well. This is the direction of the force, and this is the displacement from here to here. From here to here is the displacement. So angle between the force and the displacement, if you look at this angle is greater than 90. Therefore, cos theta is negative. Therefore, the work done is negative. So by drawing this diagram, the concept of this negative work done is clear, right? So that is all about this problem. I will be soon uploading few more videos on work energy power and very good numericals as I proceed further. So keep watching. Thank you.